Our next session is on game theory, and this comes from chapter 14 of your textbook. Just a note that game theory is a tool for analyzing decision making when you've got rivalrous kind of situations. So it could be between spouses or girlfriend and boyfriend, and they're having an argument, politicians, notorious for needing to use this, athletes, people, sports competitors, prisoners, etc. So we're trying to guess what your rival is going to do. The topics that we're going to cover from chapter 14 are static games. We're going to look at a repeated dynamic game, but there's certain parts that you can leave out. You can leave out sequential dynamic games. You can also leave out auctions and behavioral game theory from this chapter. Okay, so as I was saying, it's a set of tools. Game theory is a set of tools that economists, political scientists, military analysts, and so on can use to try and analyze this decision making in these rivalrous kind of situations by your various players. So it's like we're playing a game, and everybody's got a strategy. And if it's firms we're talking about, we've spoken about oligopolies and the importance of having a strategy and considering what your rival's up to. We're going to take an example today. This is a fun example. And we're going to assume we've got two contestants, and they've each given a set of two balls. Okay, one says split, and the other's marked steal. And they're going to look at these balls and decide which one to use. And it's going to make a difference as to what happens to a certain amount of jackpot money. Okay, whether they choose to split or steal. If both choose split, they're each going to receive half the jackpot amount. If one chooses steal and the other chooses split, the person who chooses steal is going to get the entire jackpot, and the other one who chose split is going to leave with nothing. If both choose to steal, neither contestant wins any money at all. Okay, so those are the rules of the game. I want you now to go to the two links to the game called Golden Balls, and I want you to watch the following clips before you proceed. And prior to doing this, at the beginning of these video clips, I want you to think about what you would choose. Would you choose, if you were a contestant on this show, would you choose to split or steal? And what are the consequences of what your rival does to what's going to happen in terms of how much of the jackpot you're going to walk away with? So have a look at these clips before you proceed with the rest of the lecture. Okay. After having watched those, you can think of the table on the next page as representing the various payoffs of the different decisions that these two rivals can engage with. But it shows you the various possibilities, the various possible actions that both players can take, either, for example, to split or to steal. And, for example, the way you interpret this always is you say, given what player 2 is going to do, what is player 1's best response? So, for example, you start by reading across the top row. You say, what will player 1 do? So given that player 2 is going to split, chooses to split. Okay, let's just get the highlighter here. Given that it chooses to split, player 1's payout will be, if player 1 therefore as a result chooses to split, they'll get half the jackpot. That'll be the payoff. Up in the top right hand corner of each quadrant is the payoff to player 1, here and here. So given that player 2 splits, player 1's best response is, will it be to split and get half the jackpot, or to steal and get the entire jackpot? Well, you can see that this is better. They're going to choose to steal. And so you can therefore read across the second row and see, given that if player 2 decides to steal, not to share, what would player 1's better choice be? And this is how you interpret those tables. We're going to look at an example further on. Okay, so let's just go to the next part. So you can see from this that the player 1's payoff or firm one, or whoever's at the top of the table, their payoff is always in the top right-hand corner of each quadrant, up here at the top. So there it is. Whereas player 2, this player over here, their payoff is always at the bottom left-hand corner of each quadrant. And that's how you interpret that. So firms, therefore, act or rivals engage in strategic behavior, a set of actions that they take to increase their profits, taking into account what other firms are going to do. You've got certain knowledge, players have knowledge about the rules, the different payoffs. If your rival does the following, what's the likely consequences for you? And all firms are obviously trying to maximize their profit in this game. So we can look at this in terms of if it's consumers, we can look at the payoff being utilities, for producers, profits. And we can apply it to both consumer theory and to production, etc. So a couple of assumptions that we make throughout is that players are interested in maximizing their payoffs. And all players have got common knowledge, again, about the rules of the game, about the payoffs, that they want to maximize, all players want to maximize their payoffs and so on. A static game is one in which each player acts only once and the players act simultaneously. So this is not like a game of chess. A game of chess would be a sequential game where one player moves first and then the other decides as a result what they're going to do in response to that move. This is a static game where both players must act once and simultaneously. And you don't know, therefore, what the rival's going to do. So you need to predict ahead. Okay, if your rival does X, what's my best response? A dynamic game is one in which players move either sequentially, like a game of chess, one moves first, then the other, or a dynamic game can be when you repeat, say, a static game, you play another round of it. So you are choosing actions here simultaneously in these static games, like rock, paper, scissors. If you're playing that, you're both doing it simultaneously, and you're trying to predict what the other's going to do. You have complete information, as we said, about your payoff function, what the different profit scenarios are going to be like as a consequence, but you have imperfect information about your rival's moves. And that's why this whole game theory has been developed surrounding that. We're going to assume we're going to play this once. So in the Corno and Bertrand model, play it for, say, 1/4 and see what happens as a result. Okay. We're going to go through the concepts of dominant, what is a dominant strategy for a firm, and the prisoner's dilemma. So you'll see more about what that means as we go through this. Please just make a note that you can leave out iterated elimination of strictly dominated strategies and that table. There's a reference there, so you can leave that out of the section from your textbook. So as I said to you, a normal form representation is just a fancy name for the table with the payoffs and the various alternative actions that the firms can take. Right, so the example we're going to take today is of 2 airlines. You can consider any 2 airlines. The textbook takes American and United, and they say that each firm can take one of 2 possible actions. They can either take a high output scenario, choose to fly 64,000 passengers between 2 cities every quarter, or a low output strategy of only 48,000 passengers. Okay, so each firm, 2 scenarios, just to keep it simple for now, either a low or a high output strategy. Because the firms are both making these decisions simultaneously, you can't wait to see what your rival's going to do. Okay, so you've got to try and maximize your profits based on what you believe the other firm is going to do. What is your best profit maximizing response? So if the other firm chooses a low output strategy, what would your best reaction be? If they choose a high output strategy, what would be your best profit maximizing response to that? So basically, firms are playing a non-cooperative game of imperfect information. They're not cooperating. They're not forming a cartel. the advantage of that would be it would take away this uncertainty, this kind of need for developing strategies surrounding all this uncertainty. So we're going to look at the following table to understand how this works and how you interpret it. Ignore the lines for now. I'll explain that as we go through it. But what this table shows you, once again, are the various alternative outputs that the firms can make and the resultant payoffs. Okay, and remember the interpretation of the table. I always like to start with the firm or the individual at the top, and remember the thinking is, what is American Airlines' best profit maximizing response given what it believes the other firm here, United, is going to do? So you therefore always have to start, like I said, when we were looking at best response curves, we always start off with the axis on the axis of the other firm. Here you start by reading off. If you're looking at America's best response, you start with United and you start here. So we're looking across the first row of that table. If you believe that United is going to charge, or is going to produce rather, here this is an output, is going to produce the higher output of 64, what then is America's best response? Would it be to also produce a high output of 64, or would it be to produce a low output of 48? And what we need to compare are these values here in the top right-hand corner, the profit. So we're looking across this first row, we're looking across this row, okay? And we're wanting to compare if given, and you can ignore, you can put your hand over the bottom row of that table and say, given that United's producing a high output, if that's what they choose to do, what would our best response be? Would it be to produce a high output and earn a profit of 4.1? Or would it be to produce a low output of 48 and earn a profit of 3.8? Well, we can see that 4.1 is higher. We can give this a tick, and we can see that that is what America's best response is if it believes United will produce a high output. What the textbook does is to put a line through what it won't do. I find it easier to put a tick or a star for the one firm, rather than going through what it won't do. But that's what the textbook chooses to do. So it puts a line, says won't produce that output, America. Right, now we need to see if we're planning and we're developing a strategy. If we believe, we start with United again and we look across the second row, if we believe United Airlines is going to produce a low output of 48, what would our best profit maximizing response be if we are American? Would it be to produce a high output of 64, and this will be our profit, 5.1, or would it be to produce a low output of 48 and earn 4.6? Well, once again, this over here, the high output produces a higher profit than over here. If we produce 48, we'll only earn 4.6. So you can give that a tick again, or you can rule this out. We won't do that. So we find that actually American Airlines has a dominant strategy. And even with all this uncertainty, we don't know whether United's going to choose a high or low output. American Airlines has a dominant strategy to produce the high output of 64. In both instances, will do that, regardless of what United does. So now what we can do is to go through this and to see what's going to be the case for United. Okay, right. In this instance, we're going to read down the columns. Okay, just getting the pen here. Right, so if we're looking at United's best response, we've got to start with American Airlines. So we're going to read down the columns. So given, first of all, if we assume American Airlines is going to produce this, an output of 64, what is United's best response? Is it to produce a high output, or is it to produce a low output? So we've got to compare the payoffs, and the profit to United Airlines is shown in the bottom left-hand corner of each quadrant. So given that America is going to produce a high output, we can ignore the second column. Looking down this column, yeah. Okay, would our best response as United be to produce a high output and earn 4.1 or a low output of 48 and earn 3.8? We can see that profit's higher here. This instance, let's give this a star. That firm we gave a tick. So that is higher. So we can rule this out. We're not going to produce the low output. We can rule it out. That's what the textbook does. Okay, so we can rule that out. And likewise, we can now take the situation of American Airlines producing a low output. So we're reading down, we're going down the second column. What is United's best response, given that it believes Americans is producing a low output? Would it be to produce a high output and earn 5.1, or a low output of 48 and earn 4.6? Here again, we can see that this is higher. So we're going to rule this out. We're not going to do this. And so we find that United also has a dominant strategy. It's not, we've ruled this out. It is actually not going to produce a low output in either instance. Both cases, regardless of what American does, it's going to produce the high output of 64. So we find both firms have a dominant strategy to produce a higher output. Even given all this uncertainty, we find like a game plan here. And furthermore, there's a Nash equilibrium. And that's the quadrant that's been shaded a different color there, the top left-hand quadrant, this one here. We have a Nash equilibrium because it's like we've got a paintball splotch from each team there. Okay, we've got a tick and a star. They both are happy following their profit maximizing best response in that quadrant. So we find that a dominant strategy is a strategy that produces a higher payoff, regardless really of what the other firm is doing. So for both output combinations, we find it has a dominant strategy, each firm, to produce the higher output. So we went through this in the particular example. So we found that American had a dominant strategy to produce a higher output, and so did United. There's one striking feature about this game, and I don't know if you noticed it from that table, is that even though both firms are in a Nash equilibrium, they're following their dominant strategy, and that dominant strategy is to each produce a high output. They're actually not doing the best they can. They're actually not maximizing their joint profits. Let's go back to that table and have a look. Okay, so we found that they were in Nash equilibrium here. But is that the very best they could be doing? No. This quadrant over here is actually, it represents the maximum joint profits. They could each be earning 4.6 million, so instead of 4.1. So why aren't they operating there? What's the problem? And the answer is that there's a lack of trust. Can you see that if they were actually to collude, if they were to form a cartel and agree to restrict output and to both produce the lower output of 48 and move to this quadrant here, restricting output, both producing the lower output of 48, they would actually maximize their profits. The problem is, though, is that without collusion or an explicit contract, an agreement to both reduce output, there's this lack of trust. If you don't trust your rival, and you end up producing a lower output, and they produce a higher output, your profits won't be as great. So without a lack of trust, the best you can do is this quadrant here. But if you were able to collude, you would move to that bottom right-hand quadrant. And this is actually called the prisoner's dilemma. Let's take an example of the prisoner's dilemma. It's a game in which all players have dominant strategies that result in profits that are inferior to what they could achieve if they used cooperation or cooperative strategy. So an example of the prisoner's dilemma, and why it's called this, is that two people are arrested for a minor crime. And the police take them for questioning, and they say to each person separately, we have evidence to put you in prison, each of you in prison for 1 year. If you confess and your rival stays silent, your partner in crime, stays silent, he will get 5 years and you'll go free. If you both confess, you'll each get 2 years in prison. And I want you to take a moment. Typically in lectures, I ask the students what they would do, okay? And I'd like you to take a moment to think about that, to think about the consequences of the various choices and what you would opt for in this prisoner's dilemma. Would you confess or would you stay silent? We can put this into a normal form representation, like we did like you can do for a firm. And we see that it shows you the various payoffs. Here, that's prison time. Okay, so we have a negative here. So because it's going to prison, the higher the value, the worse it is, the longer you're going to prison for. So once again, you can look at what is Alice's best response, given you start with what she believes Alex is going to do. All right. So if she believes Alex is going to confess, you're going to look across the top row, ignoring the second row, look across the top row. If she believes Alex confesses, what is her best response? Let's give this a tick. Alice, a tick in each instance. Would it be to confess and go to prison for 2 years, or to deny and go to prison for 5? Which is better? Obviously this. Shorter prison time. Okay, so if Alex confesses, her best response would be to confess. First row. However, if Alex denies, what is Alice's best response? Would it be to confess and get no time in prison, go scot-free, or to get a year in prison? Well, this is clearly better. So we find that there's a dominant strategy. Alice has, regardless of what Alex does, her dominant strategy is actually to confess. She's not going to do this. Okay. Dominant strategy to confess. Now let's have a look at the best response for Alex now. Okay. So if we want to see what Alex is going to do, we have to start with what he thinks Alice is going to be up to. So if Alex believes, we're looking down this column now, the first column, you can ignore the second column. If Alex believes Alex is going to confess, is Alex's best response, let's give it a star, to confess and go to prison for 2 years, or to deny and go to prison for 5? Well, we can clearly see that this is better. He only goes to prison for a shorter time. So he's going to confess. If Alice confesses, Alex is going to confess. Now looking down the second column here, ignoring the first, if Alice denies, what is Alex's best response? Is it to confess and go scot-free, or to deny and get a year in prison? We can see that's clearly better. It's not going to do this. So once again, we find that Alex has a dominant strategy to confess. And they're actually both in Nash equilibrium here in this quadrant. Paintball splotch, if you like, from both sides in that quadrant. So they both are very likely, and if you play this over and over again, you see the outcome is likely to be that they both confess. Is that actually the best that they could do? Is that the best overall outcome for both? No. If you look at that table carefully, you can see that the best outcome would actually be this bottom right-hand quadrant, where they only go to prison, each go to prison for 1 year. And that's if they deny, if they keep quiet. So why don't they do that? Why are they likely to confess? Okay. They're likely to confess, like, for example, Alice is likely to confess. You saw that that's the best response given in both instances what she believes Alex is going to do. However, why don't they both keep quiet and move to this quadrant here, where they get less prison time? It's because they don't trust each other. Okay. They think that if they keep quiet, the other one's going to confess and be better off. So with a lack of trust, you get this prisoner's dilemma. The fact that they could be better off moving to a different outcome, but because of a lack of trust, they never get there. Okay, so to sum up, how to predict an outcome. 2 players, with mostly here we're looking at 2 possible strategies to keep it simple. The payoff depends on your choice of strategy and the other guy's strategy. You only worry about maximizing your own payoff. A Nash equilibrium will occur where neither player will want to change their strategy given what the other player is doing. A dominant strategy is an action that you choose regardless of what the other player does. So if you're both following a dominant strategy, you'll definitely find you get a Nash equilibrium, even if it's not maximizing the joint profits, even if we have a prisoner's dilemma in place, like we've seen. If either or both firms lack a dominant strategy, they don't always have to have one, we might still find a Nash equilibrium and looking at their best responses. You can go through this table on your own. We're not typically going to do 3x3 representations, but you can go through this and you can, looking at it, you find that there isn't a dominant strategy for the one firm, nor is there for the other. It's looking at the paintball splotches. However, there is one quadrant where they both are maximizing their outcomes in the same place, and we find that we do get a Nash equilibrium therefore. So a best response, like we saw in your previous lecture, is a strategy that maximizes a player's payoff given what it believes the other rival is going to do, given what it believes its strategy is going to be. Okay, so we've gone through Nash equilibrium a couple of times, and I do think that it's good to have a system that you use, like as I say, star for the one firm, tick for the other, or your paintball splotches, whatever. Color the blocks, whatever it is that you prefer to do, but just a way of working out what dominant strategy there is and if there is a Nash equilibrium. I'm going to do a few more examples of these with you in your Zoom session so you can get some practice. In the examples we look at, we might find that there could be two possible Nash equilibria using pure strategies. So we can't actually predict the exact outcome that's going to occur. There may be two possibilities. So a pure strategy is when each player chooses an action with certainty. You can leave out mixed strategies where there are probabilities associated with those. We won't be looking at those in this module. Okay, so let's take an example where we might get two possible Nash equilibria occurring. Suppose there are two firms and they're considering opening up a petrol station at a highway rest stop. So there are currently no petrol stations there. There's enough physical space for at most two petrol stations. So what are they going to do? Okay, so this shows you the various payoffs. So once again, what is firm one's best response? We start with given what it believes firm two is going to do. If firm two does not enter, is firm one's best response to not enter and earn zero profit, obviously not being in the market, or to enter and earn a profit of, say, $1 million? Well, we can see that that clearly is better, higher payoff. All right. Now reading across the second row, given that you think firm two is going to enter the market, what is firm one's best response? To not enter and earn this, or to enter and earn -1? Well, to lose money is certainly not preferable, so this is better. Okay, now we're going to look at firm two. So we start with given what firm one's doing, reading down the first column, reading down this. So if you think firm one's not going to enter, what would firm two's best response be? To not enter and earn nothing, or to enter? We can see this is definitely better, should enter the market and earn that profit. But if it thinks firm one's going to enter, should firm two not enter and earn zero, or enter and earn a loss? The two firms obviously not sufficient demand for two. So we can see that this is preferable. So if you look at this, just get an eraser just to take the other detail off this. You can see from looking at this that there are two potential Nash equilibria. They shaded in the blue or green, depending on the version of the textbook that you have. So there's one here, over here. Let's just get the highlighter on again, or the pen. Okay, there's one over here, and there's one over here. So two potential Nash equilibria, one where firm 1 enters the market and firm 2 stays out, top right-hand corner, or bottom left, where firm 2 enters the market and firm 1 stays out. How do we know which one's going to happen? We don't. And it's probably a case of who moves first. Okay, so you can also use your slides and go through this and highlight the various options to see what happens. So this is very similar to the chicken game. So 2 cars in an intersection, should you wait or should you go? And certain countries don't have rules applying to this, and they see very high collision rates in a couple of countries that don't have a rule. The rule typically is whoever gets there first goes first. Okay, sometimes it goes a bit south. It goes wrong. So we can see that what should A do? Start with given what B does. If B goes, you can see A's best response would be to wait, okay, because they're only going to lose 1. So from you losing a little bit of time, but certainly better than having a major collision and having to pay that. If firm B waits, what is firm or person A in this instance, they're individuals, what is A's best response? It would be this. Okay, they win by 10, they save time instead of losing, okay, if they both wait. So we can do the same for the other firm, the other car, okay, and we find that we once again don't get a clear one quadrant representing a Nash equilibrium. We get two potential possibilities, and it depends on what happens and who moves first. Okay, so the one outcome where the one car waits and the other goes in each scenario, but which car moves first depends, and depends on who moves first. But it could result in an accident. Okay. So we don't know, and it usually will depend on the first mover. This is another example that you can go through from your textbook where Mimi wants to support her son Jeff. If he looks for work, but she doesn't want to support him otherwise, or he's got no incentive to look. Jeff wants to try to find a job only if Mimi will not support his life of indolence. So if they choose actions simultaneously, what are the pure or mixed strategy equilibria? So you can go through this and you can find that there isn't a clear Nash equilibrium in this instance, a clear outcome. So cooperation is whether players cooperate in a static game, and it depends on the payoff function. So you can recall the example with the 2 firms in an oligopoly. Here it's a duopoly, American and United, and we saw that they were in a Nash equilibrium over here, both following a dominant strategy to produce a high output, and they were both in Nash equilibrium there, following their dominant strategies. However, we saw that they weren't actually maximizing joint profits there. They would be down here. Okay. So if the firms were to cooperate and use the individually and jointly more profitable low output, they would be able to make more profit. And we said the reason that they don't do that is because of lack of trust. So that there has to be a way of getting around that lack of trust, as with the prisoner's dilemma. The final example that we want to take today is of advertising. We've spoken previously about whether it always pays to advertise. And I said to you, it actually depends. People have this concept in their heads that advertising always pays. But in oligopolies, firms' advertising often affects the rivals. So they have to take that into account and look at what is the likely strategy of the other firm. And you get 2 types of advertising. Advertising that hurts rivals, it's predatory. So if one firm advertises and the other doesn't, you're literally going to eat some of their customer base away, steal customers from them. And a typical example that's given here is in your soft drink market, like Coke and Pepsi. And this leads to a prisoner's dilemma. And firms would actually support a ban on ads. Let's have a look at this. So in the first example, okay, we can see that if we want to look at what is firm one's best response, okay, given what it believes firm two is going to do, after having done a couple of examples of these, hopefully you get to know how to interpret them. So we start with the top row. Given that firm two does not advertise, what should firm one do? Should it not advertise and earn this 2 million, or should it advertise and earn 3 million? Well, this is clearly superior, so it's going to opt to advertise. Then, what is firm one's best response given that it believes firm two will advertise? Read across the second row, the bottom. Should firm one then not, given that firm two is advertising, should firm one not advertise and earn 0, or advertise and earn 1 million? Okay, this is clearly better. 1 is more than 0. We find a dominant strategy for firm one, which is to advertise. We can rule this out. It's not going to engage in not advertising. Okay, it's not going to do that. Okay, so you can also always write this down. I always say to students, before you go and do this for the other firm, always write down that there's a dominant strategy for firm one to advertise, because sometimes at the end the table starts to look messy and you can't remember which firm is what. Okay, now we're going to do this for firm two. Okay, let's just take off the superfluous detail here. All right, let's give this one a tick. So if we're looking at firm two, we always start with given what firm one's doing. So we're reading down the columns now. We're going down here. Given that firm one, you can put your hand over the second column and ignore that while you look here. Given that firm one is not advertising, what is firm two's best response? To not advertise and earn 2 million, or to advertise and earn 3? This is clearly more, so it's going to advertise. Okay. Given that firm one advertises, now you're looking down this column, okay, should firm two not advertise and earn 0, or advertise and earn 1? This is clearly better. So we can see you can rule out it not advertising. You can rule this out, okay? And we find that that firm two has got a dominant strategy, and that's also to advertise. Okay, and furthermore, there's a Nash equilibrium here, paintball splotch from each, both advertising. Okay, so we find a dominant strategy to advertise. Is this the best that they can do? No. Looking at the top left-hand quadrant, you could see that they could potentially increase their profits by not paying to advertise. So they actually would both be better off if they didn't advertise, because advertising is simply just predatory. It's just stealing customers away from the other firm. So they both engage in it. They're actually worse off. So that's an example of the prisoner's dilemma. In national equilibrium, in the bottom right there, but they're not actually maximizing their joint profits. Okay. This is different from the situation where advertising can help rivals and increase the overall market size. And the examples that are often taken, so you can go through these examples too in your slides and look at the paintball splotches that it puts up. You can use any system, as I say, stars, ticks, splotches of different colors, shading, whatever suits you. But in this advertising game, okay, advertising brings new customers to the market. So let's go through it quickly once again. Firm one's best response, given firm two doesn't advertise, reading across the top row, firm one's best response would be to not advertise or to advertise. This is greater, so that's what it's going to do. Okay, you can rule that out. Given that firm two advertises, what firm one best response? To not advertise and earn this, or to advertise and earn that? Well, that's clearly more. So we find you can rule out it not advertising. It's got a dominant strategy. Firm one, it's got a dominant strategy to advertise. So regardless of what firm two does, we can see that it should advertise. Okay. Now let's do this for the other firm. Right. So we're reading down the columns now. What is firm 2's best response? Starting over here, given what firm 1's doing. If firm 1 does not advertise, should firm 2 not advertise and earn 2, or advertise and earn this? So that is clearly greater. It's going to do that. If firm 1 advertises, looking down the second column, should firm 2 not advertise and earn 3, or advertise and earn 5? This is clearly greater. So once again, firm 2 has a dominant strategy also to advertise. And we find that we have a Nash equilibrium there too, both following their dominant strategies to advertise. Is this a prisoner's dilemma? No, it isn't, because they actually are achieving their joint maximum profits in that quadrant of 5 million. It's the best they could be doing from all the quadrants. So it shows you that it certainly pays to advertise in that instance. And this is the case with cigarettes, because it increases the number of smokers in general in the market. Although cigarette advertising has been banned in many countries, particularly here, as we know. It was also shown that earlier, some of the first toothpaste campaigns, advert campaigns by one company in America, it was found that not only did it increase the market share of that company, but it actually brought more consumers. That they had an advert that spoke about the dangers of not brushing your teeth and the cavities, etc. And as a result of people watching it increased the number of toothpaste users in general. So it brought more consumers to the market, and it would be representative of this type of outcome. So we can certainly see that you need to consider all these things in deciding whether advertising pays or it doesn't, as with your previous lecture. There's some practice questions for you to go through that I've included, and we will go through some of the solutions to these in your Zoom session. But I hope that you found game theory fun, especially when you're watching those videos, and I hope you can see how you can apply it to